this guide, we'll walk you through the key aspects of choosing the perfect exhaust system. An aftermarket exhaust is more than just sound, though it's often the sound that grabs attention first. These systems can improve exhaust flow, boost horsepower and torque, and even reduce your vehicle's weight. Plus, available exhaust tips can give your car a distinctive and unique look. There are several types of exhaust system kits on the market. The most popular include Axle-back exhaust. This is the simplest way to change the look and sound of your car. It allows you to replace the section of the system from the rear axle to the exhaust tip. Cat-back exhaust, a system that also includes the mid-pipe. With this setup, you can further influence sound volume, performance, and weight reduction. Turbo-back exhaust, a complete set of exhaust components running from the turbocharger. This may require ECU tuning and offers even greater performance improvements. Full exhaust system. This setup includes replacing the exhaust manifolds as well. It's the most expensive option but delivers maximum benefits in terms of performance and sound transformation. For new cars under warranty, axle-back and cat-back systems are the most commonly replaced. Most car manufacturers allow these upgrades, but it's worth verifying beforehand. In the aftermarket, you'll find two main categories of exhaust systems. Replacement exhaust systems that match the factory specifications of your vehicle. Their key benefits include a quieter sound and an affordable price. These are ideal for drivers looking to replace a damaged exhaust at a lower cost than a new OEM system. They are typically made from aluminized steel. Performance exhaust systems, which differ significantly from stock solutions. They offer improved exhaust flow, a sporty sound, and a unique appearance, such as titanium or carbon fiber tips. These systems provide greater performance improvement potential when combined with further engine modifications. We'll focus on performance exhaust systems. When purchasing one, you'll often have the option to customize it for your vehicle model. For example, you can select the material the system is made of, various tip designs, the number of mufflers, or the pipe diameters. Let's consider a few options and ask ourselves, what do we want to achieve with a new exhaust system? Is the current factory setup a single or dual exhaust? Do we want to keep a single pipe or switch to dual? Or perhaps we plan to hit the track on weekends and need weight reduction along with adjustable sound dampening? Don't worry, we'll take the time to discuss the most common scenarios. If you're mainly looking to change the appearance and sound of your car, consider choosing an axle-back exhaust. There's a principle that states, the further from the engine you make changes to the exhaust system, the less impact it has on performance. However, in modern cars, factory rear mufflers can be so restrictive that replacing them might actually improve performance. Factory mufflers often feature a complex chamber design that creates higher back pressure. By removing them, you not only achieve the desired sound, but also enhance exhaust flow. This results in increased power, especially at higher RPMs. A freer exhaust flow also keeps the system cooler. When exhaust temperatures stay within limits, the engine control unit doesn't reduce fuel injection under heavy loads, meaning power remains unrestricted. The size of the muffler on a new exhaust system affects sound damping. Larger mufflers reduce sound more effectively, but even they typically produce a louder and deeper tone compared to stock systems. Straight-through mufflers are the most common in performance exhausts. They mainly reduce higher sound frequencies while allowing more bass to come through, delivering both power gains and an aggressive tone. Straight-through mufflers achieve this by using a perforated pipe running through their center. The space around the pipe is filled with sound-absorbing materials like fiberglass, steel, or ceramic fibers. In contrast, aftermarket chambered mufflers create a more classic, muscle car sound. These reduce noise by reflecting, dispersing, and canceling out sound waves, while also slowing exhaust gases within their chambers. Chamber mufflers can enhance torque at lower engine speeds, as they cause exhaust gases to expand more rapidly than straight-through mufflers. On the other hand, axle-back systems without mufflers are significantly louder, lighter, and cheaper. However, they may reduce torque at lower RPMs, especially in naturally aspirated engines. For those seeking more versatility, active exhaust systems with valves offer an excellent option. These systems let you adjust sound levels by altering the path of exhaust flow. When the valve is closed, exhaust gases pass through a muffler, reducing noise. When it's open, gases bypass the muffler entirely or flow through a less restrictive chamber, creating a more aggressive sound. Some systems allow exhaust gases to use both paths simultaneously, depending on the design. In simpler setups without a secondary circuit, valves restrict the main pipe at lower RPMs, mimicking certain factory systems. In automatic configurations, the valves adjust based on engine speed or load and can even have intermediate positions for fine-tuned sound control. Modern exhaust systems with valves often integrate directly with the car's factory wiring if such functionality exists. If not, a separate valve control system needs to be installed. Valves can be operated pneumatically or electrically, depending on the actuator type. Pneumatic systems use the car's intake to create a vacuum or rely on a dedicated vacuum pump. Electric actuators, more common in newer factory setups, are gaining popularity for their reliability and precision. It's important to ensure the valve is of high quality to avoid common issues like rattling or sticking. Alternatively, a simpler approach to sound control involves using removable inserts at the muffler tip. By screwing in or removing these inserts, you can adjust sound damping manually. While this method is lightweight and has fewer components prone to failure, it can increase back pressure, particularly at high RPMs, potentially reducing overall system efficiency. If you want to have a more significant impact on weight, performance, and sound, choose a catback exhaust system. Since late 2018, many vehicles have been manufactured with a gasoline auto particulate filter, DPF-OPF, to further reduce emissions. In such cases, look for DPF-Back, OPF-Back, or for diesel engines, DPF-Back exhaust systems. The midsection of the factory exhaust system usually includes resonators. Performance aftermarket exhaust systems often offer the option to include a new resonator or leave it out entirely. A resonator, also known as a mid-muffler, suppresses high, harsh tones that create resonance. Without a resonator, you can expect not only louder external noise, but also a drone inside the vehicle. Drone is an amplified exhaust sound that resonates within the car, often reinforced by elements like the bodywork or engine. This phenomenon is similar to the way a guitar's body amplifies the sound of its strings. Some people enjoy the drone, but in new systems with a resonator, it may still occur, though it is typically less intense or even completely eliminated. It's worth noting that a loud exhaust doesn't always mean there will be drone. If you're looking for a loud exhaust without drone, consider systems that feature Helmholtz resonators instead of traditional rear mufflers. These are empty chambers where sound waves bounce back with an inverted amplitude, canceling out certain frequencies. This principle is also used in noise-canceling headphones. Resonators in exhaust systems target and remove specific, unpleasant frequency ranges, letting through filtered, loud exhaust sound without drone. The most common Helmholtz resonators are J-pipes or more compact solutions. When choosing an exhaust system, It's important to check whether the manufacturer creates specially tuned mufflers and resonators for a specific vehicle model or simply relies on universal mufflers with appropriately shaped pipes. Many manufacturers provide sound samples of their exhaust systems and include information on whether drone is present. For setups without resonators, alternative solutions often include X-pipes, H-pipes, or Y-pipes, which are commonly used in V-engine configurations to balance pressure between the two-cylinder banks. This improves performance, smoothens the sound, and can even reduce drone in some cases. X-pipes typically enhance performance at higher RPMs, mellowing harsh tones that are otherwise more prominent in true dual exhaust systems, where pipes remain entirely separate. If you prefer a deeper tone reminiscent of muscle cars, choose an H-pipe, which can also improve torque at lower RPMs. Y-pipes are often used to transition from a single pipe to dual pipes, usually from a larger diameter to two smaller ones, or vice versa, often due to space limitations under the vehicle's chassis. A turbo-back exhaust is a system installed behind the turbocharger. In addition to the previously mentioned components, it also includes a downpipe. In cars without a turbocharger, the term headerback is used, with a front pipe located after it. In the factory configuration, depending on the country for which the vehicle is intended, elements responsible for exhaust gas purification, such as catalytic converters and diesel particulate filters, are typically located behind the manifold and turbocharger. This section also often includes a flexible joint, which reduces vibrations and compensates for the thermal expansion of the exhaust system. Aftermarket downpipes are generally available in two versions, with a high-flow catalytic converter, referred to as downpipe cat, or without a catalytic converter, referred to as downpipe catless, DCAT, or test pipe. If you opt for a downpipe without a catalytic converter, it will likely be necessary to tune the engine control unit, ECU. This is due to the presence of various sensors in this section of the exhaust system, unless the car does not have such parts from the factory. Examples of these sensors include oxygen sensors, also called lambda sensors, NOx sensors, and exhaust gas temperature sensors. If a downpipe without a catalytic converter is installed, the second oxygen sensor, which is factory installed behind the catalytic converter, will report an error and the engine will operate in limp mode. In such a case, ECU tuning is required. Alternatively, an adapter for the second oxygen sensor can be installed, or the option with a catalytic converter can be chosen. When choosing a downpipe with a high-flow catalytic converter, it is essential to ensure that it will work with the factory software or whether ECU reprogramming is necessary. Modern vehicles must meet increasingly stringent emission and noise standards, which become stricter every year. Consequently, newer factory vehicles often feature multiple catalytic converters. A new, more efficient aftermarket catalytic converter offers less exhaust resistance due to its less dense structure. Typically, it has a density of 200 cpsi, compared to factory converters with densities of 400 or 600 cpsi. The density refers to the number of channels per unit of the cross-sectional area of the catalyst monolith. Factory catalytic converters, in addition to cleaning exhaust gases, slightly dampen sound. A downpipe with a high-flow catalytic converter alters the tone and slightly increases the exhaust system's volume. A downpipe without a catalytic converter significantly increases exhaust sound levels. Let's move on to full exhaust systems, also known as engine-back exhausts. This is a no-compromise option in terms of performance and sound, but also the most expensive solution. Such a system typically includes more efficient exhaust headers and naturally aspirated engines, replacing stock exhaust manifolds. You can choose race-style long-tube headers, such as 8-into-1, which have longer pipes to maximize power at high RPMs, or tri-Y headers, which feature a stepped pipe design to improve torque across a wide RPM range. Many manufacturers use factory exhaust manifolds with uneven pipe lengths and V or boxer engines, mainly for cost saving and sound emission reasons. Aftermarket headers often have equal length pipes, improving both performance and exhaust sound. In turbocharged engines, short exhaust manifolds are used to provide a faster turbo response and maintain optimal turbocharger operating temperatures. You can also purchase a complete performance kit with a higher flow turbocharger or a conversion kit to turbocharge a naturally aspirated engine. In such cases, the exhaust system typically consists of larger diameter pipes, matched to the power level expected after installation and tuning. Besides replacing large sections of the exhaust system, individual components can also be upgraded. For example, a stock exhaust can be fitted with an aftermarket downpipe featuring a high-flow catalytic converter or an X-pipe instead of a resonator. There are also aftermarket exhaust systems that convert single mufflers into dual setups or vice versa. This often requires cutting an opening for the second exhaust tip in the bumper or replacing the rear diffuser or the entire bumper. If no ready-made options are available on the aftermarket for a specific car model, a custom solution may be necessary. Installing an axle-back or DPF-Back system usually does not require ECU tuning since it shouldn't trigger system errors. However, tuning is still recommended, as it can unlock additional power and torque. Keep in mind that for vehicles under warranty, such modifications may void the coverage. What about exhaust pipe diameter? Should you go as big as possible? Don't go overboard with increasing the diameter, match it to your vehicle's power output. This chart will help you select the right pipe size for your new exhaust system, especially if you're planning engine modifications to boost power. If your main goal is a deeper, throatier sound, you can opt for pipes that are 1/4 or half an inch larger than the factory diameter. In naturally aspirated engines, it's best to stick with stock sizes unless you plan on modifying the engine. It's worth mentioning the dynamic effects that occur in the exhaust system. As engine speed increases, so does the velocity and intensity of exhaust gas flow. Once a certain RPM threshold is crossed, the moving exhaust gases create a vacuum behind them, helping to pull residual gases out of the cylinder. At the same time, during valve overlap, fresh air is drawn in from the intake system. The result? Improved cylinder filling and an increase in torque. However, if the pipes are too large, exhaust flow slows down, reducing the vacuum effect or even creating resistance. In naturally aspirated engines, this can lead to a drop in torque at lower RPMs. A larger diameter also means added weight and takes up more space. Enhancing the exhaust sound in turbo diesel engines is more challenging. Catalytic converters and filters further mute the sound, and modern diesels have the most of them. Additionally, the combustion process in a diesel engine is less abrupt, and the engine operates at lower RPMs, producing a smoother tone. A proven way to improve sound is installing larger diameter pipes after the catalytic converter and particulate filters, also known as a DPF-Back system, without mufflers. In modern diesel cars, manufacturers even install speakers to generate sporty exhaust sounds. For those interested, wave phenomena also occur in exhaust systems, primarily in high-performance and racing engines. Reflected pressure waves are used to increase power in naturally aspirated engines with large valve overlap angles. When it comes to the materials used in aftermarket performance exhaust systems, 304 stainless steel is the most common choice. It offers the best balance between cost and durability. It has excellent resistance to high temperatures and harsh weather conditions, a clean aesthetic, and a lower weight compared to aluminized steel. Exhaust systems made from T6Al4V titanium alloy are more expensive but significantly lighter. In motorsports, especially in Formula 1, a popular material is Inconel 625. It is ideal for exhaust manifolds, which endure extreme heat and vibrations, as well as for shorter exhaust system configurations. Inconel is a high-temperature, nickel-based superalloy designed for extreme heat and high-stress environments. However, it is more expensive and about twice as heavy as titanium. The most budget-friendly option is an aluminized steel exhaust system. If you're looking for the lowest cost while still improving sound and performance, this is a solid choice. However, aluminized steel systems tend to corrode quickly at the welds. Over time, pipes welded to the muffler housing may detach. These exhausts are often chosen by drivers who put their vehicles through conditions that increase the risk of mechanical damage. Repairs are cheaper, and replacing the system is far less costly than with stainless steel. It's also important to consider the muffling material inside the exhaust, such as fiberglass, steel wool, or ceramic. Over time, these materials can burn out or deteriorate. A stainless steel exhaust may look perfectly fine from the outside, but if the internal muffling material is gone, the exhaust will sound louder and take on a different tone. This can also shift the torque curve, delivering more low-end torque while reducing high-end power, particularly in naturally aspirated engines. Does exhaust material affect sound? Sound perception is subjective. What sounds different to one person may go unnoticed by another. A trained ear might detect slight differences, especially when the exhaust is made from thin-walled tubing, around 1 mm thick, which can vibrate and produce resonance. However, in most cases, the differences are hard to notice, especially if the tubing is 1.5 mm thick, preventing unwanted ringing effects. Human hearing perceives frequencies below 1000 Hz and above 5000 Hz as quieter compared to 1000 Hz sounds of the same intensity. The same principle applies to exhaust tips. They can slightly alter the sound, but the difference is usually minimal unless comparing drastically different designs, such as extreme differences in length, diameter, or shape, for example, a perforated and smooth inner surface. Even small details, like whether the tip is slanted or straight, can be detected by sensitive ears. Sound changes are generally more noticeable outside the car than inside the cabin. Before purchasing a new exhaust system, it's worth familiarizing yourself with the regulations in the area where you'll be driving your modified vehicle. This will help you avoid any potential legal issues. The main concerns are local emissions and noise regulations. Keep in mind that some neighbors might not appreciate being woken up in the morning by the roar of your new exhaust system. Manufacturers often provide information about the system's certification and the conditions under which it can be used. Now, a few words about replacing exhaust system components. In the case of a partial replacement, it's usually enough to unbolt the old section and install the new one, which is connected using flanges, clamps, or brackets. The set should also include appropriate gaskets. In some cases, it may be necessary to cut the exhaust pipe at the point specified by the manufacturer. The connection involves either inserting the new pipe into the existing system or aligning both pipes and securing them with a connector included in the set. Before installation, it's a good idea to assess the condition of the existing exhaust system and its mounting points to the chassis. If the system is heavily corroded or damaged, you may need to replace additional components. If you're planning to replace the exhaust yourself, in addition to basic tools such as a jack and wrenches, you'll also need rust remover, a hammer, a saw, sandpaper, and a torch. Don't forget about safety. Wear protective goggles and gloves. After installation, check for leaks. You can do this by spraying soapy water on the connections. If bubbles appear, there is a leak. You can also listen for escaping exhaust gases or carefully feel for airflow with your hand, keeping a safe distance. If necessary, tighten the connections. Sometimes, parts may get slightly bent during transport, so it's worth checking everything and straightening minor dents. As a last resort, high-temperature sealants designed for exhaust systems can be used, provided the manufacturer allows it. Be careful not to contaminate the catalytic converter, filters, or sensors with sealant. A properly installed exhaust system should be airtight. If there are any leaks, the best solution is to file a warranty claim for the faulty exhaust system. Happy modifying!